Hi, this is a video explanation of the Connect Chapter 6 homework, number 6. So here you're asked to calculate the enthalpy of formation of a compound, carbon disulfide, from its elements. And the key here is remembering what enthalpy of formation is. This is the heat generated or required when a compound is made from its constituent elements. I think usually when you've done these type of problems, you've been given kind of a goal reaction. Well, here, the biggest hint I can give at the beginning that might solve the problem for a lot of you if you're having trouble is that you need to figure out that goal reaction yourself. And you want to use the constituent elements that you have information for. So you can define the formation of carbon disulfide in terms of carbon and sulfur. And you guys have seen other forms of sulfur before. It's oftentimes given as S8, these molecules consisting of 8 sulfur atoms. But here you don't have any information about that, so you want to take what you're given. So let's go ahead and draw up that reaction. We have carbon in the form of graphite. We want to define a reaction of that reacting with rhombic sulfur, and rhombic is just the mineral structure of that material, forming carbon disulfide. Now it does have to be balanced, so I'm going to need 2 rhombic sulfurs for every 1 carbon. And I'm leaving out, generally you should have all the states of matter, I'm leaving them out just for the essence of time on this video. Okay, so this is our goal reaction. Now we want to go through and find the reactions and products in these other reactions that we have information about. Because if we can define any reaction in terms of other reactions, we can use Hess's law to combine the enthalpies together as well. So I've circled the graphite, the rhombic sulfur, and the carbon disulfide in these reactions. Now we just need to think about what we need to do to these equations to make them fit in to our goal reaction. So what I mean by that is, for example, with the graphite, we have 1 mole of graphite reacting in the goal reaction, 1 mole reacting here, so we're not going to need to do anything to this reaction. But the sulfur, on the other hand, we have 2 moles of sulfur in our goal reaction, so we're going to want to multiply this whole reaction by 2, and that means not just the coefficients on the reactions and products, but also the enthalpy of the reaction. Now the third reaction here gives us the carbon disulfide, but it's shown as a reactant, and in our goal reaction it's a product. So we're going to multiply this whole reaction by -1. When we do that, that's the same as stating the reaction in the opposite direction. And when we do that, you can see here this reaction is a combustion reaction, carbon disulfide reacting with oxygen, and it gives off heat. That delta H is negative, so if we flip the direction around on this, this exothermic reaction will become endothermic. It will take energy to form carbon disulfide from carbon dioxide and sulfur dioxide. So when we multiply that enthalpy of the reaction by -1, the sign will flip on it. Okay, so generally now we can just kind of add together these enthalpies, but we want to make sure that this reaction actually works when it's combined in this way. So we're going to go ahead and write out all of these reactions. Carbon in the form of graphite plus O2 yields CO2, and we're going to write them out in the forms that we want them in. So what I mean by that is once we've multiplied this whole thing throughout by 2. So when we do that, we get 2 rhombic sulfurs plus 2 O2s, yielding 2 SO2s. And then lastly, this third reaction in the reverse direction, CO2 plus 2 SO2, yielding carbon disulfide and 3 O2s. And so let's also list the enthalpies of each of these reactions. I didn't have to do anything to that first one, 393.5. These are all kilojoules per mole. And then The second one I did have to multiply by 2, so that comes out to be 592.8. And the third one is just that same value, that magnitude's not different when it's in the reverse direction, but the sign has switched. So let's make sure all of our products and reactants are canceling appropriately. What's going on here is the reason why we cancel out stuff if we see it on the reactant and product side is that we have SO2 being formed from the second reaction, but the same 2 moles of it are being used in the third reaction, and so therefore they cancel. So sulfur dioxide cancels. I see 1 mole of carbon dioxide on each side, and then my oxygens, I see 3 oxygens between these 2 reactions, and then I also have 3 oxygens here. So, these problems can be challenging at first, but then at the end, they're actually kind of satisfying when you cancel out everything and see that we indeed do have our goal reaction of carbon plus 2 sulfurs yielding carbon disulfide. So I think you guys know what to do now with these enthalpies, and I will leave this video at that and not give you the actual answer. But do hit me up if you have any questions about this.